Hello, students. Welcome to another week of science. So last week we were looking at chemical reactions and what chemical reactions were. We know that chemical reactions are when you combine more than one substance together and it creates something new, a new substance. You watched a video last week of someone combining baking soda, calcium chloride, and phenol red, and we saw that it changed completely. We saw gas being produced. We saw color change. And if we did this in person, we would be able to feel a temperature change as well. So we can tell that it's a chemical reaction. Today, we're going to look at another way to tell when a chemical reaction is happening, and we're going to be looking at it in nanoscale. That means really, really, really small, too small for the eye to see. Remembering the word particle, something that is way too small for the eye to see. Okay, so today we're going to be looking at this question: what does a chemical reaction look like in nanoscale? So we're going to be taking a microscope and looking really, really small. What is happening in a chemical reaction in nanoscale? Okay, so we're going to start off with two substances here. We're going to call them substance A and substance B. Looking at substance A and B under a microscope, we can see in nanoscale that substance A is made up of a green particle. We're going to call it a molecule, so a green molecule and a blue molecule. Okay, substance B is created with a red molecule and two yellow molecules. Okay, so we can see substance A and B. Now, in our chemical reaction, when you combine substances A and B, something happens in the nanoscale in that chemical reaction, and it turns into C and D. If you look at the nanoscale and the molecules that make up C and D, you might notice something interesting. Okay, I'm going to give you a moment to look at these particles, A, B, C, and D, and see if you notice anything with the molecules. I'm going to give you a second to look at it carefully and see if you notice anything with them. Okay, if you need some more time, pause it. But if you're ready and you notice something, I'm going to share that with you. Okay, what I notice is that in C, we see that substance C is made up of a blue molecule and two yellow molecules. Well, I can actually find those molecules in A and B. Substance B has those two yellow molecules, and substance A has that blue one. And when I look at molecule D, it's made up of the red and the green molecule. And of course, we can find that in A and B. In substance B, we have the red molecule, and in substance A, we have the green molecule. So when I look at these substances, you can actually find the same molecules. They're just shifted and moved around. So now I'm wondering, in chemical reactions, how do those molecules break apart and move around to create new ones? How does that happen? Well, we're going to take a closer look, okay? So we know that when we combine substance A and substance B together, they create something new, substance C and D. And we're going to look at how that happens, okay? So let's take our microscope. We're going to look at some substance A. Now remember, substance A is the green and blue molecules attached. Let's add some substance B in there. So now we have substance A and B. Now, when we mix them together, of course, these molecules are moving around, okay? They're moving around and they're bumping into each other, okay? When they bump into each other and they're moving around and mixing, something really interesting happens. So let's zoom in on this pair right here. We're looking at substance B hitting substance A when they're mixing, and let's see what happens when substance B collides or bumps into substance A. Okay, let's take a closer look. Here we have substance B that's about to bump into substance A. When that happens, sometimes these molecules can break apart just like that. Okay, so now they're not attached anymore. And when they break apart, they have to attach to something else. So they're moving and moving around, and then they attach to new particles and new molecules. And now we can see we have two new particles. We have two new substances. We have substance C and D. Okay, so when those molecules are bumping into each other, they break apart and they attach in different ways to create new substances. Okay, we started off with substance A and substance B. They hit each other while they're mixing, and then their molecules break apart and then move and change and attach in different ways to create new substances like C and D. Okay, I'm going to introduce some new vocabulary words here, so please, please, please pay attention. Let's look at substances A and B. We started off with substances A and B. Those are called our reactants. I'm going to say that one more time. Reactants. Okay, we started off with A and B. Those are our reactants. That is the substances we are starting with. Okay. After the chemical reaction, we ended up with something new. We ended up with C and D. Those are called our products. I'm going to say that again. Products. One more time. Products. These substances that you end up with are called the products. You produce them. Okay, so we start off with reactants and we end with products. Okay, now one really quick way to tell if there has been a chemical reaction, of course, is a new substance is created or a new product, which means if you're looking at these molecules, the products have to look different than the reactants. Okay, they're arranged in different ways. They may be made up of the same things, but they are moved around and shifted and changed. So they are completely different. Okay. We're going to go over another example and we're going to do some on together before you do your assignment on your own. Okay, so let's look at one that you might know. Okay, so here we have our reactants. Okay, in our reactants, I'm going to see if you can figure this out as we go along. Okay, in this chemical reaction, we have hydrogen. Okay, hydrogen is two hydrogen molecules that are bonded together, and we have oxygen. Okay, so those two is what we're starting off with. We're starting off with hydrogen and oxygen. Those two are called our reactants. One more time, reactants. That's what we're starting off with. Okay, when these two are mixed together, there's a chemical reaction and it changes. It changes into something new. And what it changes into is water. It creates water molecules. Water molecules are made up of one oxygen molecule and two hydrogen molecules, so it looks like that. Now they look different than how they were in the beginning, so they are our products. They're what we come up with, what happens after the reaction. Okay, and these are completely different from what we started from, so we know it's a chemical reaction. Okay, we have reactants and products. We started off with hydrogen and oxygen, and we ended up with water, our product. Now I'm going to show you some examples and I want to see if you can guess it on your own before you do your assignment. This is some practice, so please take time to think about it before you move on to your assignment, okay? I'm going to show you this example first, okay? Go ahead and look at your reactants. Look carefully at those molecules. Now look at your products. See if you notice anything and decide if yes, this is a chemical reaction because it has new products, or no, the products are the same and this is not a chemical reaction. What do you think? Give it a moment. Well, looking at this, we see that yes, this is a chemical reaction because our products are different. We started off with a red molecule and two yellow molecules together, and then one green molecule. But what we ended up with was something completely different. We have a red molecule, and the green one has the two yellow molecules attached to it. So those look different from how it started. Okay, let's do another example. Here we have this one. Look at the reactants. Look at the product. Think about whether, yes, it is a chemical reaction, or no, it is not a chemical reaction. All right. This is not a chemical reaction. The products and the reactants are the same. We have the same two blue molecules and one red molecule, and that ended up the same. They are the same. It is not a chemical reaction. Okay, Here's another one. This next one's going to be a little tricky. Go ahead and look at your products and your reactants. Decide whether this is a chemical reaction or if it is not a chemical reaction. This is a tricky one. Think carefully. Okay, this one is a chemical reaction. It is a chemical reaction because even though we have the green molecule and the yellow that is stayed the same, the red and the yellow broke apart and now it is different. So even though part of it is the same, there is a new part. Okay, so we still have a different part, and so that is still a chemical reaction. If any part of it changes, it is still a chemical reaction. Okay, so that one was a little bit tricky. All right, so you're going to do a few more of these on your own in your assignment today. You're going to be looking at those pictures and determining if it is a chemical reaction or not. Make sure you're looking at the reactants and the products to see if they're the same or different. Okay, you're going to be answering this question: what does a chemical reaction look like in nanoscale? You're going to be looking at those images and decide whether or not it's a chemical reaction. Good luck today, and if you need to go back to this video to review, you can absolutely do that before you finish out your assignment. Okay, make sure you do finish the form and submit it before you click turn in on Google Classroom. Good luck today.